3. The question is, how do we show values of x greater than minus 2? Greater than minus 2. Look at the greater than sign. It looks like this. It looks like this, doesn't it? It's telling you to the right, to the right. The less than sign is like this. It's telling you to the left, to the left. So you don't need anyone telling you, okay, it should be on the positive side. Come on, it's obvious from the sign, isn't it? But you go this way. And that is it. Greater than minus 2. Because this is minus 2 and it goes on. Now, you're not going to have any big circle in the middle because 2 is not included in the possible values for x. X is strictly greater than minus 2. It's not or equal to. Because it can never be equal to minus 2, you're not going to really have a big dot on minus 2. Okay? But if you had greater than or equal to minus 2, I'm going to draw a big dot here, just like we did in the very first video. Next question, which is simple as this one as well, says for 5x less than or equal to 3x plus 7. So the first thing you want to do is to make x the subject. Okay, solve for x first. And that's going to be by subtracting 3x from both sides. So you're collecting like terms by doing that. 5x minus 3x is 2x. 7 is on this side. You've got less than or equal to. Finally, you divide both sides by a positive number 2. And because you're dividing by a positive number, this sign remains the same. But if you were to divide them by minus 2, this sign will have to change as well. And this is still going to be minus 7 over 2. All right, so now we have that. Oh, why is my line just like this? I mean, what's happening to me? All right, 7 over 2. And don't tell me, hey, you forgot to convert that to mixed fraction, because, I mean, that's not even the area we're interested in. So less than or equal to, less than tells you go to the left. So yes, we're happy. But because it is or equal to, we put a dot there, like, okay, we know that this 7 over 2 point is one of them, is one of the solutions to the problem. The third question says, solve for 3x minus 5 greater than 6x plus 10. And just like the other one, we will want to collect like terms and make x the subject. You can tell me what to do, right? Okay, tell me then. Should we subtract 6x? Okay. That's 3x minus 6x greater than. Take this minus 5 to the other side. So it is 10 plus 5. And this gives you minus 3x greater than 15. Now we're going to divide both sides by a negative number. Are you scared now? Divide 15 by a negative number, it gives you minus 5. But what happens to this sign which says greater than? It changes to less than. Because if you ever have to multiply or divide both sides by a negative number, all right, the sign must flip or must flip over. Okay, that's only for multiplication or division of a negative number. If you're adding or subtracting negative number, it's got absolutely nothing to do with the sign. I mean, with the inequality sign. So obviously, this is just going to be on the number line as less than minus 5 means that it goes to the left, to the left, to the left. And you're not going to shade or make any dot here because it is not part of the solution. All right, now to the more tricky bits. I want you to pay very serious attention to what I'm about to say. Time is not good. Time is not good. I might just have to take some more time from you guys. It was noisy. All right. So number 4, minus 10. I bet you've seen this question somewhere before and you're like, I'm always having issues with this one because it is a compound inequality problem. Compound in the sense that they are saying two things at once. They're saying two things. What they're saying here is that minus 10 is less than or equal to 2x plus 3 and 2x plus 3 is less than 6. So it's like a simultaneous problem. But take note,